Hey everyone, welcome back. Today we're going to be doing Ottergram on BugForge. This particular version of Ottergram is a SQL injection vulnerability, which is a really fun one. Um, so before we get in, I just want to give a real quick overview, and I mean a quick overview of SQL injection. Um, this is not at all a comprehensive um, tutorial on how to everything you can do with SQL injection. Okay, this is just a really quick kind of what it is, give you an idea about it, and hopefully give you a base for doing some additional research and additional labs. So, what is SQL injection? Well, at its core, it's a vulnerability that allows an attacker to interfere with the SQL query that an application sends to the database. So if there's a SQL injection vulnerability, it can result in confidential data exposure. It can result in data being deleted. And in some cases, depending on the implementation, it could even lead to RCE, which could cause a complete server compromise. So it's a severe uh, vulnerability. There's a lot of different things that you can do with it. In this video, we're only going to touch on a couple. But so just to give kind of a quick example, right? So this top one here, this might be the normal query, right? Select all from users where username equals admin. Well, if that username, if that admin part is built from user input, and the user input is concatenated directly into the query, there's potential that an attacker might be able to inject something like this. So basically, what they would be injecting is this um, apostrophe right after the username, and then or one equals one, or some other statement that always evaluates to true. And then these dashes at the end here, the slide um, kind of did an auto correct, but this is two dashes right here, right after the one, and then there's a space following the second dash. What that's doing is it's commenting out the rest of the query. So anything that might be after the username is just being commented out. So essentially, what this is doing is it's saying, give me all the information from the users table where the username is admin or true, right? So what it does in effect is it gives you all of the user information. One caveat with this is you need to be very careful with using or one equals one. I'm using this um, as an example, just to kind of illustrate the point, but you do want to be careful with this, because if you're not sure where the query is being used, if it's being used in another part of the application, say in a delete or an update statement, and you've introduced this clause that evaluates to always evaluates to true, it could end up being a really bad day. And as a penetration tester or a security researcher, you don't want to be responsible for that. So just be very careful with this. There's a lot of other better things that you can use, but like I said, I just wanted to use that to illustrate the point. So, what would be the general recommendation for preventing a SQL injection? So the first one is don't concatenate user input directly into the SQL query. You want to use parameterized queries uh, and prepared statements to ensure that the user input is treated as literal data and not as executable code. So this code here in green, this is an example from Python. Each language has a slightly different implementation, depends on what library is available in the language. So I'm not going too deep into the implementation aspect of this, but what you can see is that they're using the question mark there as a placeholder for where the input is going to go, and then the input is passed in separately after this is already evaluated. So what happens with this is, in my previous example, I had that apostrophe or 1 = 1. And in that case, because it was being concatenated directly into the query, that or clause was being evaluated. And in this case, it's not. So the database would, or the query would be looking for a user with the literal username admin apostrophe or 1 = 1, and it's not going to find it. So that's the big deal here, is that the parameterized queries and the prepared statements ensure that the user input is treated as data and not as code. Obviously, another just general hygiene recommendation is you don't want to be storing passwords in plain text in your database. You don't want to use any kind of like encoding. You don't want to store them in base 64. You don't want to use any kind of weak thing like MD5 or anything like that. You want to use a secure encryption, something like bcrypt. Basically, just make sure you're not storing them in plain text or using an easily recoverable encoding or anything like that. So the last point here, input validation doesn't really hurt, but anytime you're talking about SQL injection, input validation should be used as a secondary or a supplementary control in addition to parameterized queries and prepared statements, and not as the primary protection for these. So with that, let's get into the lab for today. So I've already gone ahead and I have registered an account and I've gotten logged in. And as you can see, this is an Instagram-like application, but it's with otters, so it's better. So if you look around the application, we can like posts, we can comment on posts. Otter, I can post that. You can look at users' profiles, and if you come over to our proxy here, and you find that request where you looked for the when you navigated to the user profile, what you can see here is that it's returning all of the data associated with that user. All right, so this is telling me that it's finding it from somewhere. Okay, so what I'm going to do is I'll resend that over to my replay, and I'll resend this. Now, what I want to do is I want to try to figure out. Well, let's back up. I'm getting ahead of myself. So, admin and 1 = 1. Now, remember, I mentioned you want to be careful with the or 1 = 1. The biggest reason you want to be careful with that is because that would, when you use an or with an always true statement, that's going to apply to everything. When you use an and, this is very specific to this. So this whole um, statement right here is only going to be true if both of these uh, conditions are true. Right. So let me make sure that this is URL encoded and send this. Okay. So I still get the information back. So what I'm going to do is I'm going to work in the convert um, pane down here in Kaido. This just kind of helps with the URL encoding, makes it a little bit easier to work with. So I'm going to change this now from an always true statement, the 1 equals 1, to 1 equals 2, which is false. And like I said, uh, the whole statement will only evaluate to true if both conditions are true. So what I'm doing now is I'm introducing a false statement or a false condition here in 1 equals 2. I'm going to apply that to the request and send it, and I don't expect to get anything back. So I don't. I get user not found, right? So that confirms that we have a SQL injection and that our input is being evaluated. So what I want to do now is I want to try to figure out how many columns or how many rows this query is returning, right? So I'm going to use a union select. And what a union select does is it allows me to get data from another table besides the one that is currently in use. Right. So the thing you have to remember with a union select is that your union select has to return the same number of rows as the original query. So I'll show you what that means. So union select, and just to save time, I already know that there are 7 rows returned. Hey everyone, sorry for the interruption. I realized as I was watching this back that I didn't really explain how to figure out the number of columns using the union select, or number of rows, excuse me. Um, I kind of skipped over it and I said, I'm just going to save time. And then watching it back, I realized that doesn't really help anybody. So um, I'm just going back and I'm adding this into the video instead of re-recording the whole thing. So forgive me. So what I've done is I've gone back here and I've got union select 1 and then the comment. So you can see that the user is not found. And basically all you want to do is you just want to keep um, incrementing this until you get up to the right number. And now you get that back. Okay. There's another way that you can do this. You can use order by. And this is kind of the opposite, right? If there's a uh, um, if that the number that you're trying to order by, basically what you're doing is you're telling the database to return um, the query ordered by that uh, row number. Okay, so if I was to say get all the way up to order by 7, okay, and then increment that up to order by 8. So now, because the query isn't returning 8 rows, it's giving me a user not found. Right? So now I know that once I've gotten the user not found error with the order by statement, I know that 7 was the right number and that the query is returning 7 rows. So with that, I'll get back to the original video. I apologize for leaving that out at first, but it felt like it was probably worth going back and explaining how I figured out that there were 7 rows being returned and not just skipping over it. So sorry about that. So send that to the query. Okay, and you see here. So now I've got this. Uh, Instead of the um, user information that we had before, now I have my input reflected here. So I've got the 1, 2, 3, 4, 5, 6, 7. Okay, so now what you want to do is you want to try to figure out what kind of database you're working with, right? And Portswigger has a really good SQL injection cheat sheet that goes through um, a lot of the different ways that you can try to figure out what type of database you're working with. Um, the funny thing about this particular lab is that I'll just tell you it's using a SQLite database, and the Portswigger um, cheat sheet doesn't have SQLite on it. So I'm going to go through kind of what I did to fully enumerate this database, and then what I did um, to get the flag. So what I want to do first is figure out what version of the database I'm using. So I can use SQLite version, helps if I type it correctly. Send that. I don't think I typed it correctly. Hmm. Oh, I see what I did. I instead of it was just getting added on there instead of that's the thing. It was you got to be a little bit careful when you're using this. If you're using Kaido, if you don't have the right uh, data highlighted when you go to apply to selected editor, it's just going to concatenate it on. It's not going to um, replace the right thing. So sorry about that. Let me fix myself here. And I can highlight all this, URL encode it, and send. And now we get the database version. So we're know we're working with SQLite 3.44.2. Okay, so now go back here, make sure that's highlighted. And now what I want to do is I want to try to extract the tables. So what I'm going to do, because there's more than one table, I'm going to use a group concat with table name, EBL underscore name from SQLite master where, and this is just a way for me to uh, be more specific in what I'm asking for back, where type equals table. Go ahead and apply that and send it. And you see we get the list of tables back here. So we've got user, SQLi sequence, posts, likes, and comments, right? Usually when things begin with SQLite, it's probably not something that's super interesting for us. Um, Typically, that's going to be things that are kind of default and not really going to have the information that we want in them. But never say never, right? Let me re-highlight this. So now what I want to do is I want to get the column names out of um, the users table, right? The users is the most interesting one for me right now. So what I want to do is group concat name from pragma table info, and then I'll pass it the table that I'm interested in. I've got an extra thing here. Apply that and send it. Okay, I've got a typo somewhere. Users, not user. And we get the column names. Okay, so ID, username, email, password, so on. So now we know kind of what we can target, and we know from the app that there's a user named admin. So what I'm going to do is just go back here, get rid of this stuff, and I'm going to say, give me username, password from users, where username equals admin. So what I'm doing here is I'm telling it to just return the username and the password from the users table. And I'm specifically telling it I want the data for the user whose username is admin. Okay, so send that, and we get the username and the password back. In this case, on BugForge, typically anytime you've got a SQL injection lab or anything like that, the bug or the flag is going to be the admin's password. Typically, that's the way it works. But in any event, we get the flag, and we've solved the lab. So I hope that this was a good introduction to SQL injection. Like I said, it was by no means a comprehensive tutorial on everything you can do with SQL injection or any of the different types of exploits that you can do with it. But at the very least, I hope you found it useful, and I hope that you enjoyed the lab. And thanks for watching. We'll see you next time.